Okay? Do not just take a chain and hook it around it. I know 1,000 times across the farm we've got away with it. You know, I've done it myself too before I started researching and getting more and more in the welding. Now I try to make sure to do what I preach as well, make sure that I'm using the correct equipment. Okay? Keep cylinders away from welding operation and closed cylinder valve when completed, and from electrical contact. These two right here are kind of a big one. You don't think about them a lot of times. But say for example you got a bottle there, and the next thing you know you're bringing your electrical leads over, and it just happens to be on a corner, and your electrical lead is wrapping around the side of that oxygen tank, okay, or acetylene tank, any cylinder, okay. Make sure it stays away from it. Look at it, follow your lead back. If you know your bottles are there, get them out of the way. Make sure your welding lead's not coming by, because if it connects to ground, you've got instantaneous, you're going to burn a hole in it, plus you've created an arc source, and now you're superheating that cylinder all in one. I've seen this happen, exactly what I just talked about. You didn't intentionally mean to do it, it was out of the way, but it was 50 feet out of the way. But you carried your welding lead across it, you got to whipping your welding lead around, and next thing you know, it's connecting, it's starting to arc off on the oxygen cylinder, and that's a bad thing. Luckily, I'd never seen anything blow up, but I walked by, and there was a small arc in between where the welding leads clipped together that was starting onto the oxygen cylinder. It could have been a lot worse than what it was, okay? I've also seen this in air arcing, and this goes with propane cylinders. Most common with propane cylinders. You're going to have a propane cylinder sitting there, you're going to be air arcing stuff out of there, and you're throwing all that flames, or even grinding, you're throwing all that material, red hot metal, right on that cylinder as well, okay? They're pretty tough. For the most part, you're not going to have a problem, but if you got one little leak, boy, it could be a bad situation. So use them, get them out of the way, and then go back to doing whatever you were doing, all right? Right here, keep oil and grease away from oxygen. The other thing that's really important is you want to make sure, especially in with brass valves, okay? If you're going to hook them onto an oxygen system, you need to make sure that it's a valve that has been cleaned and is specifically built to use oxygen. There's something else what we call sintered brass. So what it is a lot of times it's brass that's been manufactured with chemicals inside of it to help give it a lubricating property, so to say. So there's oils and so forth within the brass. It hasn't been cleaned. So right there we're taking oxygen and we're taking it right across grease and oil. Okay? Don't just grab any brass fitting or any brass valve and put it on an oxygen cylinder. Make sure that it's the correct oxygen approved valve or fitting to be able to use it. Alright? Let's talk about acetylene. Acetylene is the most widely used of all fuel gases, both welding and cutting. Page 146, left-hand column on the bottom. Read from that paragraph under acetylene. Acetylene is the most widely used of all the fuel gases, both for welding and cutting. I'm sure that's a bolded point. It's generated as the result of chemical reaction that takes place when calcium carbide comes in contact with water. Another bolded point coming up, laboratory tests have shown oxyacetylene flame temperatures up to 6,300 degrees approximately. Thus, it has a very rapid rate of preheating. Acetylene has a peculiar odor. If lighted, it burns with a smoky flame and gives off a great deal of carbon as soot. An effective welding fuel gas must possess the following characteristics. Those four bolded items there. Let's drop down into acetylene production and distribution. Out of the book, we're on the same spot on the PowerPoint, but I'm reading out of the book. Acetylene production and distribution. Commercial acetylene is made from calcium carbide, which is commonly referred to as carbide. Carbide is a gray stone-like substance that's the product of smelting coke and lime in an electric furnace. It's distributed in standard steel drums containing 100 pounds of carbide for use in acetylene generators. Several sizes are available, so forth, so forth. Let's go down to the next paragraph. Carbide is also available in a special form known as carbide processed or carbic processed carbide, which is carbide compressed into briquettes. These cakes are used in acetylene generators. They are 4 by 3 inches long and weigh about 2.5 pounds. They are packed in drums containing 40 cakes each. Like oxygen, acetylene is distributed in cylinders. Now here comes the bolded point. These cylinders are constructed differently from oxygen cylinders because of the fact that free acetylene should not be stored at a pressure above 15 psi. Right there, free should not be stored at above 15 psi. After much study, the problem of combining safety with capacity was solved by packing the cylinders with a porous material saturated with acetone. All right, so what happens is it becomes unstable. Free acetylene should not be stored above 15 psi. Acetylene can be somewhat unstable as it is, so safety solved it by packing cylinders with porous material saturated with acetone. Acetone is a liquid chemical having the property of dissolving or absorbing many times the volume of acetylene. Strong steel containers are packed completely full. Handle with care. All right. I don't see where it states it in here in the book, so we're going to talk about it a little bit. One thing that we want to make sure that goes on with acetylene cylinders is they need to always be standing upright, okay? If they're laying on their side, what happens is this chemical acetone starts to ooze out. And then next thing you know, you've got an acetylene cylinder that has part acetone in it, the rest is acetylene. That acetylene can become very explosive, very high pressure, and very volatile, okay, unpredictable. So we want to make sure acetylene cylinders are standing straight up at all times. If they are laying down, if you have to put them down, you put them up for a minimum of 4 hours before you use them. Now if you see one laying on its side, you don't know how long it's been there, don't even mess with it. Take it back to the distributor, wherever it's from, turn it in, just tell them, say, hey, I found this thing, it was laying on its side, I don't know what the deal with it is. They'll go in, they'll test it, and they'll research it on their own. You don't want to be taking the chance to save yourself 40 bucks of blowing things up, having a really bad fire, or losing your life, okay? The acetylene is drawn off through the valve. Some cylinders located in a recessed top. So in this case, it's here. Typically what we see in the welding industry is it's going to be this one in the center. Okay. Simpler in construction than an oxygen valve. It does not have to stand high pressure. It's opened only about 1.5 turns. Well, so I'm going to turn this around. I'm going to say half to 1.5. Half to 1 is typically all the more we do. Okay. That's the industry standard for the most part. You don't want any more revolutions than absolutely necessary. For the most part of our everyday handheld use torch, we will not need to go more than about 1 turn. Okay? Now occasionally you're going to turn it a half a turn and you may not see the needle rise at all. Sometimes the valves stick a little bit. It may take a little bit more than half, but if you're going past 1 turn and you still have no pressure on your gauges or your regulator, you may want to check your regulator, check the bottle, everything else, okay? Full cylinder acetylene has a pressure of about 225 psi. Small size, contains 100 cubic feet and weighs 91 pounds when full. There's two special sizes. You can get these really small units. I used to have them when I did a lot of heating and air conditioning. They were 10 to 40 cubic foot. They're a lot smaller to where you can climb. So if you can take it on a rooftop to be able to brace some stuff up, you can carry it up and down the ladder without trying to get this big 100-pound cylinder up there. They usually last. You'll be running a lot smaller size torch, smaller tips. You'll be able to usually brace things up fairly quick and use them for a couple days before they go empty. Not all acetylene in the cylinder can be used. Usually when you get down to the bottom, you'll start having some flame issues. At that point, stop. You should be down to the bottom a few pounds and be done. Remember that acetylene will burn, and the key number is at 15 psi. And never go above 15 psi. Mainly, I don't think you ever want to get above 10 myself. I very rarely have had to go above 10. Number 8 or 9 tip to cut 6, 7, 8 inch thick steel. I've still only ever had to take it to about 8 psi on the acetylene side. Right here, store the valve end up. Well protected, ventilated, dry location. If it gets become clogged with ice, you always use warm water. That's for anything. Warm water is your safest bet for any fuel gases. Whatever you do, do not use an open flame or even a heat gun. Don't use a heat gun. Get warm water. It'll open it up. So the fusible safety plugs. This is something that a lot of people get really confused about. Don't get me wrong. We want to avoid the heat and open flames in all costs. However, they are designed with fusible safety plugs they're designed to melt at boiling point of water, so 212 degrees. Okay, and of course your barometric pressure or your elevation is always going to change a little bit of that as well. But roughly 212 degrees is when the fusible safety plug melts, and at that point it's going to create this really large violent fire, outburst of flame. However, for the most part it's going to avoid an explosion of some sort. It's just going to blow around, vent off, high rate of pressure, and you'll have a pretty good sized flame going at the same time. You never want to count on that. You always want to make sure you still maintain safety procedures. However, it is important to know that if you put it in too hot a place, it very well could melt the fusible plug within it and have a violent fire as well. Never tamper with the fuse plugs. Take it to the shop immediately, or maintain your safety officer first. Contact your safety officer if you smell it and you think there's a leak around the valve. Okay, reading out of the book, page 147. Right-hand column at the top, there's some bolded items. Number 1, do not leave acetylene cylinders on their sides. Store and use them at the valve end up. Store them in a well-ventilated location. Next bullet, if the outlet becomes clogged with ice, thaw with warm water, the fusible plug with which all cylinders are provided melt at the boiling point of water. Okay, down to propane gas. Okay, halfway through that paragraph on page 147, you'll see the 5,190 degrees Fahrenheit. Okay, propane gas is a hydrocarbon present in the petroleum and natural gas, used primarily for oxy-fuel heating, cutting, soldering, and brazing. It's also used for home furnaces and so forth in different proportions. Sold and transported in steel cylinders from 20 to 100 pounds of liquefied gas. You know, there's cars that run on propane and natural gas nowadays. I don't know if there's any cars that run on propane, I'm sorry, but just natural gas. You can have bulk systems, which is why some of the shops are going to a propane gas. Bulk systems can sometimes be a lot more effective with a manifold system inside of the shop than individual bottles and cylinders. It does take quite a bit longer to bring the steel to a melting point, which means you're consuming more oxygen at the same time. MAP gas. MAP gas is a I'm reading from the book. MAP gas is a liquefied acetylene compound that's a fuel gas for oxy-fuel heating and cutting. It has a strong smell that is an aid in discovering leaks. When mixed with oxygen, the flame has a temperature of 5,300 degrees Fahrenheit. This temperature is higher than that of the oxypropane flame, but not as high as that for the oxyacetylene flame. This is a bolded item, although the heating and cutting may be somewhat slower due to the lower temperature, users indicate that overall expenses are lower due to reduced handling cost and lower gas costs. One of the things that, in my opinion, hold it back are you have to use a different type cutting tip, which are not so easy to come by in most of your welding distributor houses. Okay. MAP gas is used as a fuel gas for heating and cutting. It's distributed in bulk or in steel cylinders as well. Liquefied and stabilized so it can be used at pressures as high as 370 psi at 170 degrees. Explosive limits are lower than acetylene. Can be stored in free state and at high pressure, so you don't have the acetone issue with that. It's the safest of all the industrial fuels, and that's why a lot of companies are going to it. All right, page 148. General cylinder handling, storage, and operation safety. Number 1, regulations. This is out of your book too on page 148. I would make sure just to highlight the numbers. You're more than likely going to see them out of here. There's a few of them that we've talked about so far. However, the ones that I'm mainly concerned with are going to be 4, 5, 6, and 11. So, all cylinders with a water weight capacity of over 30 pounds shall be equipped with means of connecting a valve cap or with a collar or recess to protect the valve. Number 5, cylinders shall be kept away from radiators and other sources of heat. 6, inside of buildings, cylinders shall be stored in a well-protected, ventilated, dry location, at least 20 feet from highly combustible materials such as oil or Excelsior. Cylinders should be stored in clearly identified, assigned places away from elevators, stairs, or gangways. Assigned storage spaces shall be located where cylinders will not be knocked over or damaged by passing or falling objects, or subject to tampering by unauthorized people. Cylinders shall not be kept in unventilated enclosures such as lockers and cupboards. These are all good topics. A few of them I just want to really sink in. Number 11, oxygen cylinders and storage shall be separated from fuel gas cylinder materials. A minimum distance of 20 feet or by a non-combustible barrier at least 5 foot high, having a fire resistance rating of at least 1.5 hours. Something to remember. That's an OSHA standard right there. Okay? So the key point here is they're in storage. If they're in use in the shop, that's a different situation. Number 25. No person other than the gas supplier shall attempt to mix gas in a cylinder. No one except the owner of the cylinder or person authorized by the owner shall refill a cylinder. In the book, if you look, number 25 says no one shall tamper with safety devices on cylinders or valves. Number 26, a hammer or wrench shall not be used to open cylinder valves. If valves cannot be opened by hand, the supplier shall be notified. It's a little different than the book. Let's read out of the book, number 29. It states, before connecting a regulator to a cylinder valve, the valve shall be opened slightly and closed immediately. The valve shall be opened while standing to one side of the outlet, never in front of it. Never crack a fuel gas cylinder valve near other welding work or near sparks, flame, or other possible sources of ignition. And one of the reasons we do this is because if they've been sitting outside, now the brand new ones usually come with the shrink wrap seal around them. However, a lot of the older ones didn't, and even when you transport them around, there can get dust and foreign debris inside of the valve. So again, as you're doing it, you don't want to be looking in the valve. You want to stand to the side of the valve with the regulator before you put it on. Crack it, close it. Crack it, close it. I usually do it once or twice. Really high pressure. Make sure you're wearing your ear protection. It's really loud, but you don't need to let it vent off or blow off for a second or two. Just crack it, close it, and then you can put your regulator on. Okay. Number 32 in the book. If cylinder valves or fittings are found to be leaks, so it would be 33 here. If cylinder valves or fittings are found to have leaks that cannot be stopped by closing the valve or fitting, the cylinder shall be plainly tagged and taken outdoors away from ignition. Signs should be placed near the cylinder warning authorized personnel not to approach them. Let it bleed off till you no longer hear it leaking. All right. Manifold distribution supplies oxygen and fuel gas to a number of workstations. Again, separately, make sure they are properly labeled at all times with the correct valves and assemblies. Again, if it's oxygen, make sure that you're using an oxygen approved valve. Acetylene, make sure it's for a fuel gas and made for acetylene as well. Okay? They must be equipped with flasher esters to prevent flashback through manifold into the cylinders. Here's a typical situation here. So your shut-off valves on both of them. Here's your regulator. It's going to go into your torch system. You have a moisture drain or a drip leg within it. If it becomes plugged and you end up getting a lot of moisture in there, you can shut it off. Open this up, slowly bleed it out and let the moisture get out and then come through. Okay?